Hi students, so we meet again. This is our BSB 102 Biology 2 online course, and we're continuing, actually finishing the cycle of lectures about evolution. Today we continue to discuss some mechanisms of evolution, and we will touch on human evolution. Must be interesting. Um, First of all, the mechanisms of evolution that we so far looked at, just let's recapitulate the random mutations, natural selection, the genetic drift, gene flow, and non-random sexual replication. We applied those mechanisms to populations. Populations, we said that the unit of evolution, so to say, the thing that evolves is a population, not an individual. But how about species? You see, most people imagine evolution as a change in the assortment of species inhabiting our planet. Like there were dinosaurs, then there were primitive amphibians and fishes, and then there were birds, which sort of at first looked like dinosaurs and then evolved into what birds look now. Then there were mammals, and then the mammals, within mammals there evolved apes, and within apes evolved our own species, Homo sapiens, uh, modern man, modern human being. Uh, this is essentially correct, but we need to first define what species is. And the basic idea is that new species are being formed when populations evolve. Uh, but what are species? And, in most textbooks and encyclopedias and dictionaries of biology, you will find this definition. A species is a group of populations, right, that share major anatomical traits and are capable of interbreeding. So it's a group of populations. It's not a group of individuals. Right? We see a population as a group of individuals, but a species is a group of populations. And these groups are very similar to each other, although they live in different geographical spots. And they are able to crossbreed. And, well, there are some interesting observations pertaining to this um, uh, to this definition of species. There are specialists, zoologists who study birds, or they're called ornithologists. And ornithologists, they know it very well that there are populations of birds which look like identical twins. One population A is absolutely identical with population B. If you look at appearance, size range, the behavioral patterns, feeding, breeding, etc. But they cannot interbreed. Each of them breeds within its own group. Right? If you mix these birds, two populations of birds, they will find their mates from the original population. That's quite amazing. Right? So this introduces some complication into the definition of species. And then there is another example. See, there are two dogs pictured on the left. One of them bigger, dark, and the other one smaller and light-colored. Definitely they can interbreed, right? They can. But let's kind of expand, zoom on that. Imagine that this dog on the left is a giant how do you call it, Dane, right? Or Saint Bernard, a huge dog. And the other one is Chihuahua. Chihuahua is pocket-sized dog, right? Well, they can interbreed. Yeah, they can breed. They can have uh, healthy and fertile progeny. But the question is, will they want to do it? It's kind of unlikely. I don't know, honestly, but I'm just saying it. It's very difficult to very like strictly define a species the way we can define a population, or the way we can define a chemical element, or atom, or compound, or molecule in chemistry. The species is less uh, simple, or it's kind of not very friendly to our attempts to define. Different species, well, on the right you see a polar bear and a dog. Well, they cannot interbreed, even if they are somehow artificially forced to breed. The female will probably remain infertile, or will bear puppies that will not be very viable. There are some examples of interspecies breeding which are familiar. People know them for centuries. And for example, you can mate a, bull with a horse, right? And for the mare, and the progeny will be called how? There's a term. Well, they look kind of like bulls or kind of like cows, but they're not fertile. And also the progeny between mares and female donkeys. Mules are common. People use mules in agriculture as beasts of burden, but it's hard to continue breeding a pair of mules so that they have the original mates would have grandchildren, great grandchildren. It seems difficult, if not impossible. Also, there are known examples when somehow, I don't know, it doesn't happen often, of course, it's a rarity, but there were cases described when lions mated with tigers, and the progeny was called ligers or tyons. But again, this progeny appeared to be totally sterile. They cannot continue to have children even after one generation. So, as a rule, different species cannot interbreed. If somehow they uh, go against this rule, they still do not produce um, fertile progeny. But and again, different species cannot interbreed. Look, a wolf and a domestic dog, are they the same species, or are they different species? Well, they look similar, but not identical, right? Wolves have their distinctive features. But then if you look at breeds of dogs, artificial breeds of dogs have a huge variety of features. So that's not the defining moment. Then what is the defining moment? If they're different species, that they shouldn't be able to interbreed. Ha, they can. If a stray female dog um, finds herself in a company of wolves, it's very likely that male wolves will mate with her, and they will have puppies, and these puppies will grow up and have their own progeny. They are not sterile, they are fertile, right? So by this criterion, dogs and wolves are the same species, although in classical Linnaeus classification, taxonomy, they are different species. A domestic dog is called Canis canis in Latin, genus Canis and species Canis, and wild wolf is called Canis lupus. Right? So the genus is Canis and the species is lupus. So they sort of belong to the same group of people with the same last names, but they have each has its own first name. So generally, overall, the concept of species is difficult. And one last notice about species. Uh, can you imagine species of bacteria? You can say, well, there are huge textbooks, right? Thick books, science manuals, etc., which describe different species of bacteria. So there is a species Staphylococcus aureus, and there's a species Streptococcus pyogenes, and there's a species Bordetella pertussis, etc., etc. But you know, take it with a grain of salt. Do bacteria breed in our sense of this word? They do not replicate, they do not reproduce sexually. Bacterial cells cannot undergo meiosis. Right? They don't have pairs of homologous chromosomes. So there are no male bacteria and female bacteria. They can exchange plasmids, right? But not much more than that. They cannot really mate. So yes, Staphylococcus aureus cannot breed with Streptococcus pyogenes. But Streptococcus pyogenes is also unable to sexually breed with same species, Streptococcus pyogenes. So how do scientists define species in the world of organisms that are not reproducing sexually? They just buy common features, appearance, size, biochemistry, like what sugars do they ferment, what media do they prefer for growth, how fast they grow. Bacteria that cause tuberculosis, for example, grow about several hundred times slower than bacteria that cause a strep throat. So you can find some defining traits, features, but it's not reliable. You know, I can give you one example. When I was in Kiev Medical University, that was back in late 70s, early 80s, we had a textbook in general microbiology, and it told us that there exist 200, if I recall correctly, 241 species of Salmonella. And there was a huge table where each of these species was called by the Linnaeus binary nomenclature. Like there was Salmonella typhimurium, there was Salmonella this and Salmonella that, and yet another Salmonella. But 241 species, amazing, right? Now, in about 15, maybe 20 years from now, I saw a newer version of that old textbook that we used back then in the late 70s, and it said that there exist 6 species of Salmonella. Compare this to 241. Then when I started to teach biological disciplines here in the United States at Mississippi State University, and then at our alma mater, Mississippi University for Women, we have a textbook that kind of carefully says that bacteriologists do not quite agree on the number of species of Salmonella, but the number is somewhere between 100 and 120, something like this. And what was thought to be species number 190, number 200, number 240, number 241, those were strains. They were not species. They were simply different by the surface antigens that they carry, and so that they can be defined by specific antibodies. But that does not make them separate species. So again, the concept of species is far from being carved in stone. It's a dynamic thing. It keeps improving. We keep improving our taxonomy, especially now that we have tools to study molecular biology, molecular genetics, but still it's not quite understood just what species are. Right. Okay, but still, there is a notion in evolutionary biology that speciation occurs. And new tigers, sorry, I was looking at tigers and said new tigers. New species do arrive, every one of them, because of certain barriers that prevent crossbreeding. For example, there are barriers that we say they're prezygotic. So they work when mating has not yet occurred. Temporal isolation, frogs in ponds. There are frogs that thrive in spring, then they sort of disappear and they are replaced by frogs that prefer hot summers, and then there are frogs that prefer chilly falls and winters. So hardly winters, but falls definitely. So definitely these are three populations of frogs. Imagine one lake where you see population number one in say April, population number two in August, and population number three in November. Hardly, they will probably not crossmate, right? So it's a temporal barrier, or temporal barrier that has to do with time, tempora in Latin. Then ecological isolation, tiger and lion and tiger, very different habitats, right? Lions live in savannas where one tree stands at a distance of like half a mile or mile away from another tree. And, there's tall grass, and antelopes love to graze there, but it's very different from where tigers live. Tigers prefer thick forests, or they're forest hunters. And again, they hardly ever even see each other. Although, like I said, there are cases of mating of a lion with a tiger with some progeny, but not fertile progeny. Then there is interesting behavioral isolation. There are, you see here, this is a cricket on top row three from picture three from the left, or two from the right. A cricket, interesting creature, yes. They are very loud. Crickets they can sing so that you will find a place to hide away. And they have different mating songs, right? So when a male sings to attract a female, certain females will like it and other females will not like it. So it's very, very probable that there will be two populations of crickets forming, maybe at some distance from each other, where the mating will continue to occur within the same population, and there will be no crossbreeding or little crossbreeding. And mechanical isolation, that's the case of Chihuahua and Great Dane. When genitals are so different in size and shape, etc., that mating theoretically is possible, and these creatures can be forced to mate, but they just don't want it. So when they are in the wild, it hardly happens. Uh, and there are post-zygotic barriers when the mating has occurred, right? But the progeny is either not viable, like in the case of these rana frogs, lower row left picture, or middle picture, hybrid infertility, when a child is born from uh, the marital union between a horse and a donkey. Uh, but this mule will, it is, mules are viable, mules are very strong, right? But they are sterile. It's one generation and that's it. Or there is also an interesting barrier which is called hybrid breakdown, when the offspring, uh, it is viable and it is fertile theoretically, but it is so weird, so different from parental, uh, from parents, that it will not simply not find a mate in its population. So it's the end of the line too. So there are barriers for crossbreeding, and it is thought that as populations evolve, in some cases, a new species can arrive, and really, botanists and zoologists, they report these new species every, I don't know, maybe half a year or even more frequently. Uh, uh, my own I gotta say it, second degree uncle, a cousin of my dad. He was an entomologist. He studied insects, and he is honored in his native country as a discoverer of new species of insects. And his last name was Lopatin, and the species was called, I don't remember the genus name, but the species name was Lopatinusa. Very beautiful, right? So, reminds me of Latinaria. Okay, so speciation does occur, new species do arrive. We see it, we know it. And also, on the other hand, as you know, species go extinct. That's reality. It occurs all the time. Species that uh, are threatened by other species, or most frequently by humans, they simply go, they cannot survive, and they disappear from the face of the earth. It's pretty sad, but it's a fact. Species do become extinct. So there is a certain change in the assortment of species on our planet, although it is not quite conspicuous. It's not. It's very slow, right? You cannot observe a population of, say, worms in a bottle and like every week or every month report that, oh, new species arrived. Oh, yet another species arrived. It just doesn't happen. It doesn't work that way. It takes a lot of time. Okay, then uh, the specialists in evolutionary biology, uh, they always say that there are two different kinds of speciation, and uh, both occur, but you can't tell one from the other. The definition of these two types of speciation is based on the Latin word patria, means fatherland, place of birth, native country, etc. And according to this criterion, speciation can be allopatric or sympatric. Allo means another, right? And sym means the same. So imagine that there is a population of fishes which are all brown colored, right? So that's one species. Then these two populations became physically isolated. You can imagine that there was a pond or lake, and people made a dam, like border between two parts of or the barrier, physical barrier, the barrier made of soil, sand, etc., that prevents the population, the two new populations to come into contact with each other. So that may lead to divergence. One of them or both of them can become new species, or at least one of them can become a new species to the other one. See here in the lower left corner, it shows you two populations of fishes, and now the one of them is blue colored, so it just symbolizes a new species. Or the to summarize, allopatric speciation occurs when two evolving populations become separated by a physical barrier. Allopatric, physical barrier. Sympatric occurs when the separation is due to mechanisms other than physical barriers. One kind, one mechanism that comes to mind immediately: temporal isolation, right? Remember this example with three populations of frogs living in the same pond. Uh, they are not separated from each other by any physical barrier, but they thrive and reproduce at different times. And also in botany, in agriculture, agrobiology, there are known examples of crop plants uh, evolving as different populations and eventually becoming populations that cannot even artificially be bred because in nature they appear at different times of the year, different seasons, right? So they become, by certain criteria, they become separate species. So that's your two types of speciation. Please know it. And generally, be prepared to talk to people who object to evolution, saying that, oh, it's just, like, one common argument is that all these mechanisms like natural selection, etc., they pertain only to populations. So it's microevolution. But macroevolution, meaning appearance of arrival of new species, does not occur. Nobody saw it ever. You can argue with them saying what you learned in your class, that yes, to define a species is difficult, right? So talking about arrival of new species is always different. But there are some observations that allow us to hypothesize that speciation does occur, new species do arrive, and also, that's not a hypothesis, just a confirmed obvious fact that many species become extinct. So there is a change in this assortment of canopy of species that inhabit the world, the earth. In principle, also, when they say, I can imagine a population of butterflies evolving because of natural selection, but I cannot imagine that from this population of butterflies, suddenly we see the arrival of humans that are basketball players. I heard this argument, but this is silly. It doesn't work that way. New species do not, so they're never so dramatically differ from species from which they evolve. So in order to see arrival of basketball players, you have to go over this whole taxonomy from forms like, porifera, uh, sponges, all the way to primates and then humans. You cannot uh, rationally explain from the point of view of science, biology. There is no explanation of butterflies becoming basketball players. It's just no one ever claimed that except people who are sort of prejudiced against evolution. And talking about taxonomy, I don't want to overload you guys with details of taxonomy, but we touched on taxonomy many times. We said that, for example, vertebrates and invertebrates are not taxonomical categories, right? But flatworms and roundworms are taxonomical categories. They're two different phyla. So sometimes taxonomy is kind of counterintuitive. It's not obvious where to put a certain form of life, but generally there is this consensus that all life is classified into three domains, right? Which are, recall, I hope that you started your preparation for the final exam, so you should recap, you should revamp or update your knowledge if you don't remember this. How many domains exist? Three, right? Domain bacteria, domain archaea, and domain eukarya. Then each domain has kingdoms. For example, domain eukarya has kingdom planta, plants, kingdom animalia, right? That's animals, kingdom protista, protists, and kingdom fungi, yeast, mold, mushrooms. Then each kingdom has inside it has phyla, plural phyla, singular phylum. There are three phyla of creatures that we commonly call worms within the kingdom Animalia. There are flatworms, roundworms, and what? Segmented worms. Right. Or there is a phylum Porifera sponges. There is a phylum Echinoderms, starfishes. There is a phylum mollusks, right? And so all those organisms are invertebrate. And what about vertebrate animals? How many phyla of vertebrate animals do you guys know? Huh? One. One, chordates. Phylum Chordata in Latin, or we say chordates. Then class. And phylum Chordates, Chordata, has several classes, right? Recall classes of phylum Chordata? Fishes, right? Then amphibians, then reptiles, then birds, and then animals, right? Sorry, mammals. Forgive me, slip of the tongue. Mammals. Again, fishes, amphibians, reptiles, birds, and mammals. Five classes within one phylum, chordata, chordates. Classes are classified into orders, right? There are two orders of fishes. Remember, what are they? Cartilaginous fishes and bony fishes. Then orders are classified into families. I am not a specialist in zoology taxonomy, so I just off the top of my head, I cannot tell you, for example, what are families of bony fishes in Latin, but you definitely know that there are perches and there are basses and there are carps, etc., etc. Those are families, and within family there are genuses, and within or uh, uh, genera, actually. Genus in Latin, genus is singular and genera is plural. So within one family there are several genera, and within one genus there are several species. The word species in Latin, it's the same for uh, singular and plural. Right. So let's recall it using the class of mammals and the order, say, carnivores, and the family I'm not sure how zoologists call it, this family, but the family of animals that look like cats and dogs, right? Within this family, obviously, there is a genus dog and there is a genus cat, right? But within the genus dog, remember, there are at least two species, wolf and dog, domestic dog. Within within the genus cat, catus in Latin, there is a whole slug of different species, right? There are lions, tigers, cheetahs, and mountain lions, and finally there are domestic cats. In Latin, domestic cat is called Filus catus. So Filus refers to feline. It's a genus, and catus is cat. And Filus tigris. That's Filus tigris. Filus leoni. That's tigers and lions. So that's the classification of life in very general features. Of course, it is much more detailed if you take our for biology majors. By the way, it's maybe not mandatory, but it's an elective. If you take the evolutionary biology class, you will be introduced to a more detailed picture of taxonomy. Now, what about us, humans? How did humans evolve? First of all, let's classify us, going through all these boxes of scientific classification. To what box do we belong? Well, domain definitely Eukarya, right? Kingdom is Animalia, animals. Phylum Chordata, right? Among vertebrate animals, there are no other phyla, so that's an easy one. Then class, Mammalia. Order, primates. See, class Mammalia includes dolphins, bears, lions, opossums, huge variety of, creatures. But there is one distinct order which is called primates. Within this order, there is a suborder called Haplorhini. Rhinus is nose in Latin, so haplorhini means basically one nose. There are primates. Yes, there are primates that have split noses, more than one nose by appearance. Then there is an infraorder within the order primates. There is a suborder Simiformis, and then there's a suborder Haplorhini, and there's an infraorder of Simiformis. So it's primates that are simia in Latin is monkey. So not all primates are monkeys. There are lemurs, for example, right, which are also primates, but they're not monkeys. But there are monkeys or infraorder Simiformes in Latin, so Simiformes. Within this infraorder, there is a family Hominidae. Monkeys or monkey-like mammals are monkeys, strict sense monkeys, and apes, which are monkey-like but not quite monkeys. Right? So they are the big apes are also called Hominidae, and they are considered a special family. Within this family, there is a tribe. I honestly, I don't know much about this taxonomical unit, but I believe what is written here. This tribe is Hominini in Latin, hominines. Genus Homo, right? We are genus Homo. So that's this classification of us belongs to Carl Linnaeus, right? Like most of taxonomical forms that we know today were first recorded by this super genius of the 18th century biology. Uh, within the genus Homo, there are species. Uh, there is one extant or living species, which is us, Homo sapiens. And there are, look how many are shown here. 1, 2, 3, 4, 5, 6, at least 6. I some read elsewhere that it's more than 6, but at least six uh, species of the genus Homo used to exist but do not exist anymore. They went away, disappeared. Homo erectus, Homo florensiens, Homo habilis, Homo heidelbergensis, Homo naledi, and Homo neanderthalensis. Please don't think for a second that I want you to know, but to remember by heart all, all names of all these taxonomical categories. I just want you to understand the logic of where we belong as a species. And one important thing that like take home message from this taxonomical picture is that we evolved from this family Hominida and tribe Hominini, but it doesn't mean that we are direct descendants of those big apes that we see now. For example, chimpanzees or bonobos or orangutans. We're not. Um, Specialists in taxonomy, even modern day taxonomy using genetic data, biotechnology, bioinformatics, they don't find evidence that one happy or unhappy day, I don't know, a chimpanzee just decided to become a human being. It didn't work that way. As always, you see, there were mutations. There was some kind of natural selection, genetic drift, gene flow, non-random replication, which produced several new species. Uh, this table does not tell you, and it's for a reason, that it doesn't tell you that all these Homo species derived from some species of hominids that we know now, that we see now in the zoo or in the jungle, or if we travel in the jungle. No, there were some other hominida and hominini, which, again, probably they became extinct, and one of them or several of them gave rise to 7 species of creatures that we call humans or Homo, and only one of them lives now. Others, at least 6, are out of the picture. It could not, or did not make it. Uh, so this is just a picture of different primates that you have knowledge. This A. lemur, uh, Slow-loris, funny creature, a long-tailed lemur. They are primates, right? But they're not monkey-like. They do not belong to the category Simiformes. On the other hand, there are these creatures, black and gold howler, and there is the Sulawesi or spectral tarsier, I don't know how to pronounce it, which look like monkeys, right? So within the order primates, there are separate taxonomical categories, non-simiformians and simiformians, monkey-like. Apes are also monkey-like, but they are uh, uh, separated into a special category, right, called hominids. And it is believed that some species, most likely extinct, now extinct species of hominids, gave rise to several species of human beings, and right now only one survives. That's a human being called human uh, reasonable, right? Homo sapiens, or human being knowledgeable. There were other species of this genus Homo, now extinct. For example, there was Homo erectus, means a human that stands upright. It doesn't exist anymore, extinct. Then there was Homo habilis, huge progress. It's actually, that's the species of genus Homo which learned how to make tools, learned how to tame fire, and they didn't make it anyway. And then there is this Homo sapiens, which is not very old category of a taxonomical category, and it is recent, and it is the only Homo species that still survives miraculously. It wants to kill itself for a long time, but still could not succeed. Still survives. Again, there's a little timeline that gives you some idea when these species of hominids existed. It is commonly hypothesized that our earliest progenitors from the family hominids were Australopithecus. Australo, by the way, it has nothing to do with Australia. Some students had this idea that Australopithecus is from Australia. No, Australos in Latin means southern. So actually, the skeletons of these Australopithecus were found in Africa, and Europeans, who are way north from Africa, called them southern skeletons, southern fossils. And Pithecus is actually monkey. They're not monkeys. Look at them. They don't really look like monkeys, right? They look like big apes, which stand upright, which they are still. They were short. They were not as tall as we are now, much shorter, and they were very hairy. So still, they definitely belonged to hominids, but whether or not they can be classified as genus Homo, hard to say. Then there were some other, this is Homo habilis, remember, I told you that's the huge progress from these previous forms of hominids. It not only stood upright, it not only got rid of much of facial hair because it learned how to use animal hides to warm itself. himself or herself or himself, hard to say. And why is it called habilis? Means in Latin someone who has learned a trade, somebody who knows how to make something, habilis, able to make things, able to make tools. So homo habilis, homini habilis in plural. They developed primitive uh, rocks that had one sharp side, so that was sort of the most primitive knife. They invented a spear, again making stick with like warhead of stone, of sharp stone. They lived at the time when these big woolen mammoths lived, so that's about 2 million years ago. Uh, then Homo erectus, a man who stood upright. And then there were several extinct forms of these definitely belong to genus Homo, and they were classified by paleontologists as Homo neanderthal or Homo neanderthalensis, something like this. Uh, and finally, about just 80,000 years ago, look at that, that's a very small time lapse compared to evolution of hominids 5 million, 3 million years. 80,000 years ago, first fossils were identified as living 80,000 years ago, and they, by pretty much all biological traits, they resemble uh, modern humans. Uh, there is a, see, it has poof, gone missing link. Uh, I'll elaborate on this in next uh, next slide. See, this is an Australopithecus, the most the our original relative. There were it's not a species. There were several species of Australopithecus, and I don't know how many of them are extinct. Probably most of them, if not all of them, are extinct. Then Homo sapiens evolved through several intermediate steps, like Homo habilis, Homo erectus, Homo sapiens. Uh, and there two kinds of fossils were discovered. One of them, which both can be classified as fossilized remains of Homo sapiens, but one of them was one uh, sort of box of fossils were in modern day France, a village called Cro-Magnon, and this type of Homo sapiens was called Cro-Magnon Homo sapiens. It's like direct ancestor of us. There were no other links between this kind of Homo sapiens and us. Right? But at about the same time, in Germany, in the uh, valley of the Neander River, Neanderthal in German. There was another kind of box of fossils was discovered, and they also these fossils qualify as remains of Homo sapiens, but there were different. They Homo Neanderthal men and Cro-Magnon men were different by appearance. Neanderthals were shorter. Neanderthals had slightly different shape of the skull, different facial features. They were more hairy, and at some point there
was an idea that Neanderthals were kind of backward, primitive, and Cro-Magnons were more advanced, etc. But there is very little basis to say, to conclude that, because, well, different facial features, big deal, right? Neanderthals made dwellings, made tools, knew how to tame fire, right? So they actually started to eat roasted meat, which certainly improved their physique and lifespan, etc. So they were hardly less sapiens than Homo sapiens Cro-Magnon. Uh, there is some kind of really missing link between uh, Neanderthals and Cro-Magnons. Neanderthals by themselves are this missing link, which just again, yet another time, it tells you that fossil record is never complete. There are always missing links. And again, there are people who are so against evolution that they say, until you show me every single link, from a bacterium to a butterfly to Australopithecus to baseball player Magic Johnson, I will not believe that evolution is real. Some even say that evolution is your religion, which is of course not correct. Uh, there are missing links, and nobody knows what happened to these Neanderthals and why. They had. It's hard to state that they were stupid, that they could not adapt to the environment, etc. Uh, Humans migrated from uh, central, East Central Africa north to uh, the Mediterranean coast, and then to Asia and Europe, and kind of disseminated in what is now Middle East, India, China, and European countries, Northwest. Uh, and at some point, there was a dramatic climate change. When first Homo sapiens appeared in Africa, Europe was as warm as Africa, but the ice age came, right? And these ice shields occupied most of what is now Europe and about one half of what is now Asia. And the climate in those parts became quite harsh. Winters became cold. So those humans who had already migrated there, they had to adapt. And there is evidence that both Cro-Magnons and Neanderthals adapted very well. And then, boom, Neanderthals disappeared. There is one kind of Gothic version. What really happened was that Cro-Magnons had better tools, better arrows and lances, and maybe some other primitive, but no, not that primitive tools for killing other humans. And they organized this kind of giant hunt on Neanderthals and killed them all and ate them, and that's why they survived. I don't know whether this has any scientific merit, but in any case, Neanderthals are mystery. They just disappeared from the face of the earth for no apparent reason. So that's the evolution, sort of like short history of the evolution of human beings. These slides show you the evolution of humans from uh, mere consumers, hunters, gatherers, to producers. The left slide shows you uh, Paleolithic people, uh, Cro-Magnons, but kind of less advanced Cro-Magnons that we are now. They did not know how to make stuff except tools for hunting. They did not sow and reap. They did not have factories or mines or anything. They lived by hunting and gathering. And then on the right, you see the beginning of agriculture when more advanced Cro-Magnons, probably something like 10, maybe 8, 7,000 years ago, not that far away from us, learned how to grow crops. Right? And this changed the life of human race tremendously. Uh, the, uh, the fields required care. Care was provided by members of a certain tribe. So tribes divided land into pieces which they owned. Their land became owned, and then there was a need for special people to keep all that in order and to settle disputes about ownership of land, etc. So an army appeared, armies, military, and cities eventually evolved, appeared. Cities were enclosed territories where people lived, and one city could be very friendly to visitors, but quite hostile to another city. There were these disputes about, especially about land ownership, which had to be settled by professional military. So at this point, the strictly biological evolution of humans uh, is, it doesn't stop, but we say the prehistory of the human race, of humankind, stops, and history of humankind begins. So that sort of goes beyond the scope of biology. But one last thing, I would want to give you this link, and I encourage you to read the material there. It, it gives you several interesting examples that human evolution continues. Uh, they give several examples, like they give example of positive selection of tall men in certain areas. Like northwestern Europe, men, the average height of an adult male is 6 feet, average. In the Netherlands, the tallest men, and they sort of go over the possible mechanism of what happened, etc. Then selection in favor of lactase gene. There is an enzyme called lactase which splits lactose, the basic sugar of milk, right, making us milk or dairy tolerant. And there are data from fossils and combined with molecular genetic DNA data. This evidence says that at some point of human prehistory, all humans were lactase intolerable, or lactose intolerable. So humans had no use of cows except killing them for meat. But then somehow there became the gene that coded lactose tolerance, coding an enzyme that splits lactose, became positively selected. It was a rare thing. It was a rare mutant, but some some events uh, made it advantageous for humans to save cows, to not kill them, but use their milk and make cheese and make sour cream, all these dairy products from milk. It was more economical, and it selected in favor of those who carried lactose tolerance gene. So now at this point there are plenty of people who are lactose intolerant, but still they are a minority. Most of us can tolerate lactose and can use dairy products. And this picture is sort of a jocular, humorous picture. There are different ideas of what will happen to us. Maybe we will split into several separate species, and this artist just fantasized about a new species that has abnormally, from our standpoint, abnormally large eyes. I don't know how they want to call it. That's humor, of course, but evolution does occur. We do evolve. Again, accept the idea that evolution simply means a change in the gene pool. That's the only definition that covers all biological evolution. Uh, we went over this progression from small to large doesn't work. For progression from simple to complex, also this is not a good definition because sometimes evolution works the other way, from more simple to less, or from more complex to less complex. Remember these blind fishes in the cave. Just the only reasonable and all covering, comprehensive definition of evolution is the change in the gene pool. And human populations have gene pools which do change. They do change. These examples with lactose tolerance. Then another example, I mentioned it, sickle cell anemia. Right? There are people who have a mutant hemoglobin gene, so their red blood cells do not carry oxygen as nicely as non-mutated. But if these people live in areas that are infested with malaria, they have an advantage because the parasite that causes malaria, Plasmodium malaria, cannot reproduce in sickle cell mutation harboring red blood cells. So these humans who have this mutated gene increase in numbers. They have reproductive advantage or reproductive success because they live longer, and then they leave more offspring naturally. Right. So humans do evolve, whether or not there will be an arrival of some, you know, Homo super sapiens or Homo stupidities or something. No one knows. It's kind of beyond our ability to explore scientifically. So we just leave it as an open possibility, but nothing more than that. But it doesn't cross out the idea that we evolve. We do evolve. Okay, so this is your cycle of lectures about evolution. I hope that you were not bored to death. I tried to stick to those parts of evolutionary teaching that can be understood can be comprehended by lay audience without much special education in taxonomy or population genetics, etc. It can be explained in simple terms, and I encourage you guys to read for comprehension, study your textbook, study these lectures, and learn how to explain things in words. When I hear from some students that I'm just a visual learner, so I cannot write long sentences, this does not sound right to me. People can be more visional, more auditory learners, but still, learning always means getting a concept, right? Not just memorizing the right words, but getting a certain concept. And I hope that you guys will have this concept. At least you will have a foundation for conceptual knowledge in biology. Okay, thank you so much for listening. Next cycle of lectures will be in ecology, so us and environment. And meanwhile, please do study for your third exam. I have already published it for proctors. Uh, the window of your taking it is pretty wide. It's from April 4 uh, to May 2nd, so till the very end of the semester. And also, I'm working on two documents right now. One is a list of pretty basic, simple study questions for the third midterm exam, and the other document is just your final exam, which is I'm not really sure what to put there, and I'm not publishing it even for proctors right now. It'll give me a few more days. And your window of taking that exam will be something like April 15th or April 17th, 18th to May 2nd. So to avoid the conflict of schedules, try to register for the third exam, third semester exam, as early as possible, beginning from April 4th. No, yeah. If April 4th is tomorrow, so you can start registering tomorrow. The proctors must have your third exam published, and in the nearest future, like maybe tomorrow, tonight maybe, I will publish a short list of basic study questions. Okay, till next time.